Okay, so now let us see how we can use the pointers. We have an integer with the variable name a, and we have also declared the p as the pointer. So this is star p as the integer pointer. A is holding some value, that is 14, and p is a pointer and it is holding the memory address. So since pointer holds the memory address, so it's written and declared with p equals to ampersand of a, right? So cout statement is used and you are printing the value of a and the address of a. So now if you print, just observe this, it's cout p, that is the pointer, and star of p. So since p holds the address, so if you see the output, the first output is this is a, this is the memory address of a, and OX is the hexadecimal notation of the addresses. So the second statement was cout P and cout star of P. So cout P is the memory address. So memory address was holding the memory address. So it's directly, if you write P, so it will give the memory address, and if you write star P, so it will give you the value, that is value of the variable, that is a. So a was having 14, and since the pointer was pointing to the variable a, so you'll get 14 over here. And similarly 14, since you are directly printing a, so it will give you 14. Okay, so initialization of pointer variables, how you can initialize. So there are two steps. First is, if you write something like this, integer a, and you don't give the value, so it's the unknown value, right? But if you write integer star p and you don't declare any value, and you do not write something like address of a or address of b, or if you do not initialize the pointer, so it is known as unknown location. It is not actually pointing to somewhere because you are not initializing. So how we can give the value is, it's a two-way process, or you can do it in a single statement. Either you can go for writing int star p equals to ampersand of x, or you can declare it like first int star p, that is the declaration, and then you can initialize it with p equals to ampersand of x. So this is how the pointers work. So first you have to declare it and then you have to initialize it. You can also go for the single statement, that is declaration and initialization in one go. Okay, so star is also known as dereferencing operator. Why it is known as dereferencing? Because if I say p was referencing to a, so if you want to get back to the value of whatever this p was pointing to, so you can use the star operator. So if you see this example, a is having certain value 100 and a is stored at 1024, right? So it's a is having value 100 stored at 1024. P is a pointer, integer pointer. The notation is star p. It is initialized to ampersand of a, that means it is pointing to the variable a. You can print cout a, that is a value that will give you 100, ampersand of a, that is 1024, cout p, that is the address, so it's 1024, star of p. So if you give star of p, so star will give you the value stored in a variable that is pointed by this p variable, that is the p pointer. So जहाँ पे भी आपने p use करा है, p is a pointer, p is holding the address. So if you want to dereference, if you want to see what the value of the variable is जिसको भी वो point कर रहा है, so you can use this star operator. So just use star p and you'll see the value of that particular variable. And cout ampersand of p. So you can write it directly, the address of p. So like you have used star ampersand of a, ampersand of a से उसका memory address आता है. Similarly ampersand of p से p का address आ जाता है. Okay, so this is an example of how you can use the pointers and you can add two numbers using the pointers. So it's simple way. You declare three integers. It's a, b, and r. You can name it any variable name. So declare three pointer variables. Pa is holding the reference to a, pb is holding the reference to b, and pr is holding the reference to r. That means there are three pointers, and these three pointers pointing to a, b, and r respectively. So just take the value of the variable a and b. How you can store the value is, since star used to refer to the value, so you can use it directly, pa and pb, and just apply the computation. It's a plus b, or you can write using the pointers, it's star pa plus star pb. So star refers to the value stored in a and the value stored in b. So our pr will hold the resultant and just print star of pr. Okay, so this is pointer flexibility, that refers to how you can use one pointer for many variables. That means you have three integers over here. If you see this example, it's integer a, integer b, and integer c. So if you see integer star p, that is a pointer integer that is pointing to an integer. And if you take the values, it's a, b, and c from the user. So just take the values from the user. And how you can now initialize your pointer, first is p equals to ampersand of a. That means you are pointing p to a now, and you are printing the value. Now you can change the pointer, and now you can point this pointer to b, and you can print the value of p. And similarly, p is pointing to c now, and the value of c can be printed over here. So if you see, it's star used for printing the value of pointer. And since at every line, if you see star, ampersand of a, ampersand of b, ampersand of c, so all these are changing the pointers references. First is it was pointing to a, then it is pointing to b, and then the same pointer is pointing to c. And since you all know that star is used to point, और स्टार इज यूज टू एक्सेस दी वैल्यू, सो जहाँ पे भी वो रेफरेंस कर रहा था, जहाँ भी वो पॉइंट कर रहा था, उस वेरिएबल की वैल्यू को प्रिंट करने के लिए आपने स्टार पुट करा है. सो स्टार पी एंड स्टार पी विल गिव यू द वैल्यू ऑफ ए, बी एंड सी रिस्पेक्टिवली. Okay, so this multiple pointers for one variable. That means you can create multiple pointer variables, all pointing to a single variable. So it will be something like this is the a, and then a, that is a integer variable, and you have three pointers pointing to the same variable. So it's p is also pointing to a, q is also pointing to a, and r is also pointing to a. So this is the flexibility of pointers, or how multiple pointers can access same variables. So if you see, a is an integer, star p is also holding the address of a, star q is also holding the address of a, and star r is also holding the address of a. So if you take the input c a, it and you take the value from the user, so this is value taken from the user. And if you print star p, q, and r, so all these three statements will print the same value, since all these pointers were pointing to the variable a itself. Okay, so let's see how we can work the pointers with the functions. Okay, so in this case, if you see, this is the integer function, the function that is returning an integer pointer. This is an integer pointer being returned. This is the name of the function, followed by two parameters, that is again the pointers, that is parameter, formal parameters. So you take an integer, that is int main function, you are declaring uh, a, b simple variables and a pointer. So when you take this from the user and you declare the function call, so in the function call, since you know pointers are used by reference, so you can use ampersand of a and ampersand of b. So while defining the function, so this is the definition section. In this definition section, you are returning, it's the same as the declaration portion, you are returning an integer pointer, and in the parameters you are using star px and star py. So this is just the function definition. In the function definition you are using star, and in the function call, so this is a function call, so while using the pointer, since you know the pointer holds the address, so both these addresses will go to px and py respectively. Okay, so this is the last one. Let us see how the pointers to pointers work. And this is one of the interesting fact. And see the local declarations first. You have integer a, you have p as a pointer, and you have a double pointer, that is star star q. So let us see what happens if you see this particular diagram. A is an integer and A is holding a value 58, and A is stored at some random location. This is just a number. So it's 234560 is the address where A is stored. If you see P, so P is a pointer to A. So if P is a pointer, so P must be having the address of A. So this is the address of A is stored at P, and star P is this value, that is the address, the pointer to an integer, and P itself, since it's also a variable, it's also a derived data type, so it must be stored somewhere. So it's stored at location 287650, some random location, right? So if you see the q variable, so q is declared as double pointer, and this q is storing the memory address of p. So this is the memory address of p, it's 287650. So this memory address is holding by the variable, that is the pointer q, and this is again stored at location 287870. So how double pointer works is, you have q as a pointer which is holding the address of a pointer, and therefore known as pointer to pointer. And how you can print the value, you have a as 58, you have p as holding the address of A, then you have Q which is holding the address of a pointer. So this is the double pointer. Q is your double pointer. So you can print the value directly. You can print it something like cout A if you want to print the value of A, cout star of P. So star of P would again give you the value of, see, this address is here, and this address is holding the value 58, sorry. So if you want to print through q, that means the double pointers, you can write something like cout star star of q. So if you see, the q is, the address is 287650, and on this location you have another address, that is 234560, and at this address you are having the value 58. So the output would be, it's 58, 58 and 58. Okay, so this completes the pointers and all its notation. I hope you like